In this video we're going to look at how conditional probabilities can be used alongside Venn diagrams. To begin with then, we're going to recap the basic ideas of probability, or the basic probability rules. So we've got the probability that A happens plus the probability that A doesn't happen must always equal 1. We've got the probability of A or B, or the probability of A union B is the probability of A plus the probability of B if A and B are exclusive. More generally, we've got the probability of A or B, which is the probability of A union B, is the same thing as the probability of A plus the probability of B minus the probability of A and B. And of course, A and B is the same thing as A intersect B. If we have two independent events, A and B, then the probability of A and B is the probability of A intersect B, is the probability of A times by the probability of B. More generally, the probability of A and B is the same thing as the probability of A times by the probability of B occurring given that A has occurred. And this formula can be rewritten to give us the probability that B happens given that A has happened is the probability of B and A divided by the probability of A. So for our first example, we've got events A and B are such that the probability of A is 0.55, the probability of B is 0.7, and the probability of A given that B has occurred is 0.6. We've got to find the values of the probability of A union B and the probability of B not happening given that A has happened. The fact that we know that the probability of A given B is 0.6 means that I can say that 0.6 is the probability of A given B, which is the probability of A intersect B divided by the probability of B. Rearranging that, because we know the probability of B is 0.7, we can say that 0.6 is equal to the probability of A intersect B divided by 0.7. In other words, the probability of A intersect B is 0.42. So, drawing a quick Venn diagram, we know that 0.42 is the probability that we are in the area represented by A intersect B. We know that the probability of A is 0.55, so we can write 0.13 into the area of A which does not overlap with B. We also know that the probability of B is 0.7. We've already got 0.42 of that in the intersection between A and B, so we must have 0.28 going in the area representing B but not A. From that we can see that the probability of A union B is 0.13 plus 0.42 plus 0.28, which gives me 0.83. Now we could also have achieved that answer from the fact that we know that 0.42 is the probability of A intersect B by using the rule the probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. So that's 0.55 plus the 0.7, both of which we were given. Take away the 0.42 that we found a minute or two ago, and that again gives me 0.83. To find the probability of not B given that A has occurred, then we need to use our rule for conditional probabilities. So the probability of not B given that A has occurred is the probability of not B and A divided by the probability of A. The probability that B doesn't happen and A does happen is the probability that we are in the shaded area of our Venn diagram, which is 0.13. So we've got 0.13 divided by 0.55, so 13/55 for the probability. For our second example, we've got in a raffle 184 tickets were sold. Each ticket had a different integer on it, and the numbers were consecutive numbers from 1 to 184. The tickets were all put into a hat, and the winning ticket was picked at random from the hat. The events A, B and C are defined by A is the number on the winning ticket is divisible by 5, B is the number on the winning ticket is divisible by 8, C is the number on the winning ticket is at least 30 but less than 60. So we've got to work out the probability of A, the probability of B, probability of A and B, and the probability of A intersect B intersect C to begin with. Okay, well the probability of A is 36 out of 184 because if we think about the tickets between 1 and 184, there are 36 numbers which are divisible by 5. The first one is 5, 10, 15, etc. all the way up to 180. 180 is the same thing as 36 times 5. So we've got 36 numbers out of the 184 possible numbers are divisible by 5. So the probability the number is divisible by 5 is 36 out of 184. If we think about the number 184, 184 is 23 times 8. So there are 23 numbers on the tickets that are exactly divisible by 8. So we've got a probability of 23 out of 184. Probability of A intersect B. Well, if we've got the number on the winning ticket is divisible by 5 and the number on the winning ticket is divisible by 8, that means the number on the winning ticket is divisible by 40, and the only numbers in the hat which are divisible by 40 are 40, 80, 120 and 160. So there are 4 tickets that satisfy that. So we've got a probability of 4 out of 184. For part C, we've got A intersect B intersect C, so we've got to have the number on the winning ticket is divisible by 5, the number on the winning ticket is divisible by 8, and the number on the winning ticket is at least 30 but less than 60. Well, we know that A and B together means the number on the winning ticket must be divisible by 40. So if we're going to satisfy A intersect B intersect C, we've got to have a number between 30 and 60, which is divisible by 40. And of course, there's only one such number. So we've got the probability that A intersect B intersect C is just 1 in 184. So we've got our probabilities so far. Now we've got to find the probability of A union B union C. Now at the moment we can already put in that the probability of A intersect B intersect C is 1/184th. We also know the probability of A intersect B is 4/184ths. So we can now put 3/184ths into the part of the diagram representing the part of A intersect B that does not include A intersect B intersect C. So we've got 3/184ths goes in there. Now to work any further with the Venn diagram, we're going to need to work out things like A intersect C. Well, A intersect C is the winning number is divisible by 5, but is also at least 30 but less than 60. So 30 will do, 35 will do, 40 will do, 45 will do, 50 will do, 55 will do, but 60 won't do. So A intersect C has got a probability of 6 out of 184. if we want to put in the probability for the part of A intersect C that does not include A intersect B intersect C, then that's going to be 5 184ths. Similarly, B intersect C is the winning number is divisible by 8 and at least 30 but less than 60. Well, we've got 32, 40, 48 and 56 will satisfy those conditions. So the probability of B intersect C is 4 184ths, which means that the bit of B intersect C that doesn't include A intersect B intersect C will have a probability of 3 184ths. Now, we know that the probability of A is 36 184ths. At the moment, we have got 3 plus 1 plus 5, which is 9 184ths there. So, the remaining part of A must have a probability of 27 184ths. We know that the probability of B is 23 184ths. But so far, we've got 3 184ths, 1 184th, and 3 184ths. That makes 7 184ths. So the remaining part of B is going to be 16 184ths. Now, we haven't worked out the probability of C yet, but the probability of getting a number on the winning ticket that is at least 30 but less than 60, well, there are 30 numbers that satisfy that. So we've got the probability of C is 30 184ths, but we've already got 9 184ths accounted for, so the remaining part of C must be 21 184ths. So the probability of A or B or C, we just need to add up all of the probabilities that we've got in the Venn diagram so far, and that comes to 76 184ths. For the final part, we need the probability of A or B given that C has occurred. So we've got a conditional probability to work out. Well, the probability of A or B given that C has occurred is the probability of A or B intersect C divided by the probability of C. A or B intersect C is the shaded area in the diagram. That has got a probability of 9 184ths. So the probability of A union B given that C has occurred is 9 184ths divided by 30 184ths, which is 9/30ths or 3/10ths. Now, it's worth noticing that you can do this conditional probability without having to work out, without resorting to the formula. We can do it by common sense. So, if C has occurred, then we know the winning ticket has a number which is at least 30 but less than 60. So there are 30 equally likely possibilities. If A or B has happened, then the winning ticket must be 30, 32, 35, 40, 45, 48, 50, 55 or 56, because A is the number is divisible by 5, B is the number is divisible by 8, and those are all of the numbers between 30 but less than 60 that are divisible by 5 but less divisible by 5 or divisible by 8 and less than 60. So what have we got there? We've got 9 possibilities out of 30 possibilities. So we've got a probability of A or B, given that C has occurred, is 9/30ths. Well, that's the end of this video, and in the next video we'll have... And to finish the video, there is just one question for you to have a quick go at, and as usual take it along to your lesson afterwards. And that concludes our look at using conditional probability with Venn diagrams.